see. No. Okay. Let me get my mouse. Okay, great. Oh, that's actually not what I wanted to show. Actually, I can't control that one. Screw it. Okay, I'm just gonna leave it like this. Can everyone see the slide clearly? Cool. Okay. So I'll just start. Welcome to lecture 8. We do have a bit of a cough, so we'll excuse that. And then we'll start off with some announcements. So we finished the late submissions. So we're going to be releasing every grade soon. If you are at risk of failing, we are also going to send you an email after lecture. And in addition to that, what was the other thing, Rocky? Mentors, yes. Rocky's assigning Hack Challenge mentors right now, so you can expect those shortly. So for this lecture, we're going to be talking about images. Images are a great way to make your Hack Challenge app look much nicer, and there's actually ways to store images on the backend. So imagine you have a database that stores fruits. You have an ID, and you have a quantity, which are both integers. You have the names of the fruits, which are text, and then you have how much they cost, which is a float, so represented as the real type. But if you have images, what type are you going to store them as? There's no image type. So there are 3 different ways we can do this, starting with blobs, which we'll get into first. You can also store them as files on the server. And then you can also store an image URL in the database, which is actually how we're going to be doing the demo. So let's start with blobs. What are blobs? It's essentially you have an image is just a bunch of bytes. And so if you were to look at an image in a text file, you're going to see a bunch of garbage. So let's actually take a look at this. This is what it would look like if it's in a text file, and it's essentially just the encoded binary. Now, the problem with this is that it is very large, so we don't want to waste our database's storage. It's designed for structured data, and blobs are definitely not structured, just very long string. And because of that, it's going to be very slow if you try to store blobs into the database. So we're not going to do blobs. An alternative is storing file paths. So servers are computers, meaning that you can store files on them. So you don't necessarily need to store data from within memory in your code or store it into the database. You can store it as a file on the system. So if you remember from project 5 or 6, you can, or project 6, you can SSH into your Heroku, and you can see that there are files on it. You can essentially put your image files onto that server. And the way you would do that is you would just post the image, and then it would save it onto the server itself. So this is what it would look like. You have your source folder with all your Flask and SQL Alchemy stuff, and then you also have an image, and then you have apple.png, orange.png, banana.jpg. But how would you actually store this in the data? Sure. In your database, you have the file paths of them. You have /image/apple.png, /image/orange.png, and so on and so forth. So you just store it as a text in your database. So there are benefits to this as opposed to blobs, because you're not going to be dealing with any slowness when storing things in your database. It's much easier to scale, and you don't need to deal with any special coding because these are files. There's already file input-output code that Python has. And you can also back up images asynchronously. You don't have to do it in your code. And it's, of course, nicer. Now, there are some problems, though. Maybe you don't want to store lots of images on your server, because if you make another server, you're not going to have access to those images. So how am I supposed to have multiple servers that are hosting an app? Say, if you remember from, this was the deployment lecture, one of the optimizations is clustering, where you have multiple servers for your app. If you want to try accessing an image from one of those servers, and it just so happens that the image isn't on the server, you need to store the same image on multiple servers, and then you're wasting space. So that's no good. Another issue is that if your server crashes and you lose data, you lost all your image stuff. And that will probably happen if you're using, well, it potentially can happen, but that's something that you need to handle, and that's not a great thing to have. And as I said, with clustering, you might want to separate your responsibilities. So maybe you want a server that's just responsible for hosting a web page. Maybe you don't want that server for storing images, but you'd have to store images on every server if you're trying to access the images. So the last option is storing a URL, and this is through cloud-based storage. The nice thing about cloud-based is that they are the ones that are going to take care of everything for you. They're the ones that are storing the images on their end, and you don't need to worry about the server going down and you losing your data, because they host the database and they have all the images stored on there, and all you need to do to get that image is to access the URL where they stored that image for you. So this is why we are going to use cloud-based storage. So for the demo, what Rahi's going to be showing you is we're going to be using Amazon S3 for our cloud-based storage. He's going, well, this may not actually be what he's going to do, but ideally what you do is you upload your image encoded as a base 64, because blobs are slow to store in your database, but they're also slow to send over. So this is why we want to convert a blob into a base 64, which essentially has the same information, but it's much more succinct. So when you send requests over, it's much quicker than if you to send an entire blob. And then we'll be able to retrieve the image by using the URL that Amazon S3 gives us back. And Amazon S3 is not the only image hosting service that you can use. There are other ones that you can look at as well if you would like to for a hack challenge, but this is a pretty good one. So let me pause the recording. Sounds good. Any questions before we move on to the demo? Cool.
Cool. Let's just get started. So, like we mentioned before, we're going to be using base64 to encode our images, right? So just as an example of what that looks like, this is kind of a website that lets you convert images to base64. So let's just grab some random thing that I have stored. You can upload it, and then if you click copy image, it'll copy that. Then we go to Postman. Then you paste it in, right? And it's this long, long string. It's like billion lines, right? That wasn't like a massive image. It was like 760 pixels by something. So, you know, base64 encodings are not going to be as long as blobs, but they're still pretty long. The other thing is, base64 encodings include some kind of meta information. Tells you that it's a PNG image, tells you that it's base64, and then the actual kind of encoding starts. This is what we're going to be doing in the lecture. Let's talk about how we want to do this and make sure that OBS switches properly. Oh my god, it did. Nice. Cool. So for this, we're going to be using AWS, right? We're going to have to make an S3 bucket, so we're going to be going through, you know, the process for y'all doing. aws.amazon.com, and then create an account. I've already created an account, so I can just sign in. either in this step or a later step, AWS is going to ask you for billing information. That's just because, you know, in general, a lot of services on AWS cost money, so it needs to know where to charge if you use those. But I think the S3 free trial is a year. So if your free trial has expired, you may need to make a new email. Cool. So like this isn't my Cornell email, right? This is just my personal email. Let me sign in, SDT7S. That looks like probably right? Nice. Cool. So you end up inside of the AWS Management Console. There's a bunch of stuff here, and it's kind of information overload, and I don't know what like 80% of it does. But for this specific thing, we're going to be using what's called an S3 bucket, which is a nice way of storing files online, right? So you can see that I've got this bucket, which I thought I had deleted. Delete. Okay. Now, so what we're going to do is we're going to create a bucket to store our files in, right? So I'll just call it Rahi Demo 8. The AWS region is because to communicate with AWS, you have to send AWS requests, right? Amazon wants people's experience to be as fast as possible, so they have a bunch of different servers set up in a bunch of different regions to kind of minimize latency. So in this case, we're connecting with the Ohio server, which is US East 2. This is kind of going to depend on where you are, but you do need to keep in mind what AWS region you end up connecting to, because it's going to be used a little bit later on. Anyways, here is a very important setting. You shouldn't uncheck this tick box in normal circumstances. I'm unchecking the tick box. Public access is not something you generally ever want in storage systems, right? You don't want any like random old person to be like, I want to store random stuff in this person's file system. But this is for demo purposes and for a small hackathon anyways. It's fine temporarily. If you are curious how to make these things more secure, that's a little out of the scope of this lecture. I'd recommend looking into it though, because in general, you do not want to uncheck this. Cool. Versioning is fine. All of the other settings you can kind of leave alone. I think none of those. Yeah, that's fine. Then create bucket. What? Oh, I acknowledge that I'm a bad person. Yes. Beautiful. The bucket's created. There's a little bit more kind of finagling we're going to have to do before we can really get started coding. So in your AWS console, you're going to kind of go to your security credentials. This is because, you know, we need some way of identifying who you are to make sure that you should have access to this personal bucket, right? So that's going to be in this thing called access keys. Don't ever share your access keys. That's not the best idea for me to be showing you, but it's fine because that's a kind of less secret one. But, you know, if I were to create a new access key, and then I click show, this is something that you should never show people. Just not a great thing to do. I'll probably have to delete this after this. Yeah. So we can see that I created a new one. Which is the newest one? This is the newest one. Okay. Let's delete that. But what you would end up doing is you would kind of take your access key and secret key and you would want to store it somewhere, because we're going to need this in the very next step, which is, if I go over to my terminal, you're going to have to go into your root directory. So there's a couple different ways of doing this. If you are on Linux or Mac, you get to type slightly fewer characters. You can just type cd, and it'll take you to your root directory. For what it's worth, cd tilde also does this, for the most part. I think on Macs it's a little bit different. If you are on PowerShell, you have to explicitly type cd tilde. If you type for example, if I cd into dev, and then I type, say, cd, nothing happens on Windows, because it's like, oh, you didn't say where you want to go, so we're going to keep you right where we are. Whereas cd tilde takes you to root. Cool. In your root directory, you want to make a .aws folder. It has to be named .aws because this is how Amazon kind of figures out where to get your credentials from. You can see I can't because I already have one. So let's cd into .aws. And then in this folder, you're going to need 2 files. I have 3 here because one of these has my actual credentials that I should not be showing you in it. So you will need to make a config and credentials file. There's a couple different ways of doing this via the terminal. Obviously, you could open your favorite text editor in this folder and do this there, or, you know, these files aren't going to be long. You could use Vim to open them. You could use Nano to open them. Whatever your favorite text editor is in the terminal. In Mac, I don't remember if these come pre-installed or not. They're not that hard to install in a terminal. You can quickly look up how to install terminal editors if you don't already have one. In any case, let's look at what the config looks like. So you need this default flag, and then you need to say region equals, and this is why I said remember your region. Were we US East 2 or were we US West 2? Yeah, we're East 2. I'm not remembering. Because it's needed in your configuration so that it knows where to look for things. So this is pretty much going to be just copied for most of y'all because I think you guys should all be in US East 2. But anyways. Cool. The other one is the credentials. Let me make sure that I don't open the wrong one. Cool. You also have a little kind of bracket default at the top, which signals this is your kind of default user. You can define other configurations here by changing the word. Default just indicates, hey, if I don't specify anything, do this, right? And then here you actually define where your access key and secret key are. So you type exactly this, AWS access key ID equals, and then paste in your thing. Or AWS secret access key equals your secret key. Mine are hidden because secrecy. Yeah, I'm just, you know, if you feel like using Nano, looks slightly different. How do I close things? That's how you do it. Cool. And I think with that, we can get coding. If anyone doesn't have any beginning questions. Nope. All right. So, first thing you might notice is we have about 1 billion imports now. We don't just have SQL Alchemy, we also have whatever the heck MIME types is, and pills, and Boto3. So what these are is things we're going to need. Let me kind of go through. But this is the AWS interfacing library for Python. Python is, I think, like the only language that has it named something that isn't just like AWS API library or something. They call it Boto3. Date time is because we're going to be storing when the image was created. Bytes.io is because we have been slightly misleading in saying we're going to be storing things as base 64. Because, you know, base 64 things are strings. And when you download an image, you probably don't want to download a long, long string. So Bytes.io is going to convert our base 64 into a byte string, which can actually be properly read as an image. MIME types is how we're going to figure out what our file extension is. It has some handy things called guess extension and guess type. Guess type is going to figure out what MIME type it is. And MIME types, there's a bunch of different things. If you remember from the little Postman section at the beginning, we had an images/PNG, right? So we're going to feed it some like base 64 byte information and be like, hey, guess what MIME type this is? And it'll guess, you know, something, PNG, JPEG, whatever. And then we feed that into guess extension, which figures out, oh, this is probably a PNG file, which is useful for kind of generating URLs. PIL is just an image interaction library. Random is for something called salting, which we'll get to a little bit later on, but, you know, just as a little teaser, it's for generating like a random string to uniquely identify various things. In this case, we're going to be using it to name our images. And it just makes things a little bit more secure. RE is for regular expressions, which we're going to be using for some other stuff later. And that images here, right? We could be storing videos, we could be storing, yeah, let's let it store GIFs, right? Stuff like that. So it's going to be class asset db.model, and then for now we'll pass. Because we need to do some So, for example, let's say a variable called extensions, and it's just going to be a list of things we're okay with. So, you know, like PNG is probably a good idea, JPEG, I think I said GIF, and then actual JPEG. We're going to need to know what our current directory is for later on, and you'll see why later. That's going to be based here, os.get current working directory. Then we're going to need the name of our S3 bucket. That's going to be used in some kind of API called later on. S3 bucket equals, I named it Rahi Demo 8, I think? Probably. That should be the name of whatever bucket you created, if that needed to be said. And then the S3 base URL is a super long string, which is why I have this pulled up, because I don't remember it off the top of my head. https:// S3 bucket, which is why we need that, dot S3 -us east to .amazon aws.com. And this is going to be the region you are using, right? For those of you that haven't seen this in Python before, this is what's called a format string. It's very nice because we can just stick the variable name in the string where we want it to go and enclose it in these braces. And the braces tell Python, hey, stick a variable name in here. You can kind of also escape that if you, oh, okay, I guess a backslash does. I don't actually know how to escape it. But you can see if I didn't put this F in front, it would be like, we see you put braces there, but they're going to be normal braces because this is a string. But it'll still syntax highlight. But F, it registers, hey, stick an S3 bucket in there. Cool. So now let's go into the actual class. Like all SQL Alchemy things, we need a table name. So let's just call this asset. We're going to need columns, right? So we're going to say id equals db.column, db.integer, primary key is true. Everything is going to have some sort of base URL attached to it, right? Which is going to be, hey, where should we start looking for things? That's going to be base URL equals db.column, db.string, and then we don't want it to be nullable because if we had a nullable base URL, that would kind of defeat the purpose. Salt. This is, again, going to be the name of our file and a kind of secure way of storing it. But in terms of what it is, it's just a string. All of these are going to be nullable equals false. What else is there? The file extension is going to be another string. We've got a lot of strings here. Oops. Show the width and the height. db.column, db.integer, nullable equals false, height equals db. And this is in pixels, by the way. Perfect. And then, all right, we imported date time, I think, so that we could say when it was made. So created at equals db.column, db.SQL has a handy column called date time. We can just do that. Cool. And then, since this is a class in Python, we need to have a constructor. We're going to be using kwargs like we have for the past few things. So now the question is, what do we need? If you remember the Postman kind of request I made at the very beginning, all that we really passed it was image data. And that image data just contained the base64 encoding of the image. So, what do we do with that? Well, we'll figure that out later. So let's just say we create something with it. So self.create, quargs.get image data. Cool. Problem solved until later. Kind of like everything else, we're going to need serialize, which is pretty trivial in this one. It's just going to return the URL, which is going to be another format string, self.base URL / self.salt, self.extension. Dot. And so you can kind of see what this is doing, right? The URL is going to be whatever the base URL / the name of the file, right? I'm sure you guys have seen kind of websites that are like this. You go to the website and it's like, oh, there's the URL / a file, and then it downloads the file for you. Same idea. And then, oops, that should not be capital. Created at self.created at, what did I do? Oh, forgot the comma. And that should be converted to a string. Cool. That's all hunky-dory. Now our technical debt has caught up to us, and we should probably actually make this create function. So it gets passed in self and image data. Now a lot of this can throw some wacky exceptions. So we're gonna stick everything in this little try except block. First, we need to figure out what the extension is, right? We've been passed in image data, but we've allowed a bunch of different things, right? We've allowed PNG, JPEG, JPG, GIF. I don't actually know how these are different. Might be interesting. So we need to figure that out, right? Because we need to store the extension to be able to actually download the image, right? That's going to be in the URL. So this is where MIME types comes in. So we're going to say x equals guess extension of guess type. Remember I said we were going to feed that in. Image data 0, because guess type actually returns an array, I believe. Yeah, or it returns a tuple. And then extension, we're going to start from 1. This is because extension actually returns it with the dot. But in our URL, we've decided to keep the dot in there just to make things slightly more readable. So we're stripping that dot off. Cool. But, you know, somebody might have tried to hit us with a bamboozle and say that, you know, I'm going to try uploading an MP4 file. We haven't let people upload MP4 files. So we're going to say if x not in extensions, then we're just going to raise an exception. F extension x not supported. Cool. Next, we're going to do the salt thing that I mentioned earlier. We're going to generate that. So we're going to say salt equals this dot join, and hear me out because this is kind of funky. Random dot system random of dot choice string dot ASCII uppercase plus string dot digits for in range 16. Oops. Okay. So what is this doing? Essentially, it's creating a random letter out of the uppercase letters and the digits and making it 16 characters long and then joining it all together, right? Because system random is going to return all of this stuff for us. And so we're going to want to put that all in a string, right? Because join kind of flattens something that's iterable, which this is going to give us. It's going to give us a bunch of different uppercase letters and digits that aren't already in string format, but we can iterate over them, so we're just flattening them out into a string. Then, earlier, I showed you that the base64 string had some metadata. The metadata isn't necessary now that we know the extension and we know what it is. So let's just kind of strip that off. And this is where the regular expressions come in. If you guys don't know how regular expressions work, they're very weird and complicated and difficult to explain if you're not used to them. I definitely recommend looking them up on your own time because they're very cool, but if this looks like black magic to you, that's fine. So we're going to say doot data image plus base 64, comma, image data. And to just kind of give you an idea of what this is doing, it's finding a regular expression within our image data string that matches this. So it's looking for, where data image is, up to where base 64 ends, and then replacing all of that with an empty string for some context. The actual image data, we have to kind of get out of this base 64, right? Because this is a string that's been encoded, so let's decode it. So this is where base 64 comes in, base 64 slash b64 decode. We can just pass in the image string. Perfect. So now if we hover over, we can see that it is a bytes variable, which is great. Because, we're out of string land, so we're not sorting strings anymore, at least. But now we want the actual image. So we're going to say image equals image.open, because we imported image from Pillow, remember, image data. And image.open can take a couple different things. It can take like a file, for example, but if you notice, it can take bytes as one of the things it does. I don't think, it does let me. There we go. Cool. Now we need to actually create what goes in the database, right? Because if you've noticed, we've been doing a bunch of kind of boilerplate work, but we haven't actually populated any of that yet. Except for my DID, I guess, because that's automatic. So, self.base URL equals just what we already defined to be the constant base URL. Self.salt equals salt. Self.extension equals ext. Because we already done a lot of this work, right? Self.width we get from Pillow, so that's going to be image.width. Self.height equals image.height, which we get from Pillow. And then self.createdAt equals datetime.datetime.now. Cool. And then the last thing we need to do is actually upload the image to S3. So, let's figure out what the file name is, right? Because we need to combine the salt with the extension to get that. The file name is just going to be salt.ext. And then we're going to upload it. Except once again, we've decided to use the trick of pretending we have something that we haven't actually written. So we'll have to deal with that in a bit. For now, let's say this function is over, and we should probably fix the fact that we haven't accepted anything here. I think that's where it matches? No, it's one. No, it is here. Except exception as eat. Print couldn't create image. And then that's the error. What did I do? Oh, got the indentation wrong. Is it still wrong? No, okay, that's fine. So now let's figure out what this upload function is. Is this where it goes? No. Yes, def upload. Oh, should probably have a space there. And so upload is just going to take in an image and an image file name. And again, we have to surround everything in a big try catch block, or try except block, because Python. So, this is going to be some weird stuff we have to do. Because S3 wants us to upload a physical image, which, notably, we don't have stored anywhere. So we need to temporarily store this image somewhere. That's why at the very beginning we decided to get the current working directory from the OS. If I scroll back up, you can see we've stored our base directory as this. What is this yelling me about? Nothing. Cool. So we're going to say the temporary location of the image is going to come from our base directory / and then the file name of the image. So it's just going to take whatever directory we're currently in and then stick the image at there, right? Because the image file name is already something .png or .gif or whatever. And then, since we already have it as a pillow image, pillow has a handy save function for us. So we just save it as the file name. Or, sorry, save it in the temp location. I got tricked by my autocomplete. Now that we have the image saved locally, we have to upload it to S3. To do that, we have to kind of configure Bodo a little bit. So let's figure out what to do. We need something called a client to interact with AWS. In this case, we need a Bodo 3 client. Specifically, we need something to interact with S3, right? Makes sense so far. Then, we just need the client to upload the file from the temporary location to the S3 bucket. Cool. But when you just kind of immediately upload something, by kind of default, it gets set to private and has some permissions that make it so that other people can't access it. So we need to fix that. We're going to say S3 resource is bodo3.resource S3. And this time we're saying resource because we're modifying the actual S3 kind of things itself rather than just interacting and pushing and pulling from it. The object ACL, so-called because you will see, is the object ACL from the S3 bucket image file name. So this is kind of getting some properties of our object. And we need to let S3 know that this is a public object and anybody can read this. So we're going to take our object ACL and we're going to put some information. In this case, public read. Makes sense. And then we don't want to clutter up our local directory, right? If every time somebody posted an image, we saved it, that would take up so much space. So we're just going to remove the image. Finally, we're going to accept an exception as E. And then not console.log, I've been typing in too much JavaScript recently. Print image upload failure E. And that is all the db.py code, assuming I don't have an error. I don't know why this is underlined in red. I don't think I did anything wrong. If other people don't see something I did wrong, probably VS Code getting mad for no reason. But we do need to set up the route, right? So we have this upload route that we haven't yet defined. If you remember from the request at the beginning, all that they pass in is the base64 encoding, right? So if you're wondering how to do images in the hack challenge, say, pretty much how you would work if you wanted to follow along with this is front end would have to somehow use a library to generate a base64 encoding of whatever image they're trying to upload. There are plenty of front end libraries for this. That's not your problem to figure out. All that y'all really have to do is kind of give them the API specification, work with them on that, and deploy it so that they can access it and work together to make sure that everything's working fine. But in terms of the actual encoding, that is their job. DW. Cool. So, as always, body equals json.loads request.data. In this case, we just want the image data, which is body.get image data. And then, some standard checking stuff. If image data is none, return failure response. No image with a 400. And then we need to create the asset, right? So we're going to create the asset using image data equals image data as Quargs works, right? And then finally, db.session.add asset, db.session.commit, and return success response asset, not assert, serialize to 1. This is yelling at me because I didn't actually import asset. Let's quickly go up and do that. Let's alphabetize. Import from db import asset db. Okay. And now, I guess hopefully this works. So if I python 3 app.py this. Oh wait, that's the wrong folder. My computer's been weirdly slow recently. Now we try python 3 app.pying. Cannot import name s3 base URL. Where's the error? Oh. Okay. Don't know how that got in there. Cool. All right, so I guess let's see if this works. So if I go back to Postman, and then I try uploading this, what response did we get? Internal server error. Love to see it. Let's see what happened. Not null constraint fate. Failed. Why? Asset.base URL. But I assigned those. Right? Couldn't create image embedded null byte. What? I guess I try a different image. What do I have that's like small? I don't know. Let's just make one. Okay, maybe there was a problem with just like that image. Let's save that in pictures. I don't know. Demo. And so now we go to pictures, demo. And we copy that. And then I'm not doing that, I'm scrolling. How's that? Again, what happened? Okay, let's see what's going on in db.py. What did I do? Nah. Whatever. Self.create, args.get image data. Okay. Print image data. Image data. And then I guess print setup complete. I don't know what's going on here. Okay. Let's cd into starter. And then try Python 3ing that again. Oh. We got to activate the virtual environment. The virtual environment is in the starter folder. Okay. So now let's try this again. Okay, and did it print anything? Couldn't create image, embedded null byte. That should be fine. What's up? Oh. Where? Image.open here. I forgot we imported bytes.io. Is it bytes.io.data? No, just bytes.io. Okay, let's see if that solves the problem. This is why all of the imports we needed were actually important. We tried postmanning, and that one worked. Beautiful. Okay, so now if we just try going there, that's not what I wanted. Okay, so we go here. Access denied. This happened to me last time I did this demo too. Let me look at the code to see what I did wrong. Did I miss a line? Last time it was because I missed a line. Let's see. So in upload we have mystery claim for photo minus 3, upload file image template, 3 resources, photo 3.resources 3. Yeah. Oops. Weird. Okay. Well, it was uploaded, so right now the only main problem is, I think, a read issue. Because if I go to this browser, and we go into the S3 bucket, let's see if there's anything inside. There is nothing. That's strange. Did I spell something wrong? Photo3.resource S3. That should be image template S3 bucket. And I called it Rahi Demo 8. Rahi Demo 8. It is US East 2, I think. Yeah, US East 2. Okay. I'll figure this out. I don't want to waste y'all's time while I debug. So I'll post the corrected code later on Campus Wire or something, because we are over time and I don't want to take more of y'all's time than we need to. So I'll post the corrected code probably tomorrow or so when I figured out what's going on with this. But I hope that at least gave y'all most of an idea of how we do this. Cool. All right, I guess if anybody has anything specific they want.
Okay, y'all. So after some too long debugging and running a literal file diff on this code and the correct code, I found out what the problem was. It's a Python thing, because of course it is, but it is on line 75. I've opened this in Vim just because it's such a quick fix that I didn't feel like opening VS Code for it. But here, let me just quickly add a little. Yeah, there we go. That was the problem. I forgot to put self in my upload function, and that was messing with everything because it wasn't getting called. And Python doesn't tell you things like that. Like, you know, if you go to this upload function, it like, you know, you think it would throw an error, but no, it just is like, oh, that doesn't exist. You called a function that doesn't exist. Oh well. Like, I know this is my fault, but it really feels like it's not. Anyways, that should fix that problem, so let's try running it. So if I close out of that, and then try, let me clear and then zoom in a little bit. And if I python3 app.py, now it should be working. Cool. So now let me switch to Postman, which I think is this. Yeah. Let's go to this. This is the exact same thing I was doing before. You can tell that I was testing it earlier and it worked. So let's click this. Exciting, it gave us a URL. We'll take a look at that in a second. But for now, let's look at our S3 bucket and just make sure that something was uploaded. So let me refresh this page. And voila, we have something in the bucket, right? And so if we go to this URL now, you couldn't tell. You can probably see that the URL disappeared, but it opened a kind of pop-up box asking me where I want to save the file. So it's working, right? And so if you want the front end to be able to download images, all they have to do is hit that route and it will return the image. So there's the image demo finally done. Sorry that this took so long. That was such a small error that took me unreasonably long to debug, and I'm very sorry about that. But thank y'all for watching.